Yes, no, maybe? Okay, so if I take a derivative, what am I gonna get? dy dx here, what'd you get here?
3x squared over x cubed. Nothing. Oh, bro, come on. Wait. Yeah. No.
It's the same answer.
Wait, it's 3 over x.
The same answer. Same answer. Except you just do u equal to x cubed, and then du is equal to 3x squared, so it'll be 3x squared over x cubed. Now that's, I mean, it's correct. It's same answer. So sorry.
I mean, that's the
Okay, that's nice. All right, no, how about a second one?
3 over x.
No.
I think that.
So complicated.
Oh, it is J rule.
Yes. I got it.
What is this?
Slate got it. He just said what he says.
He's just a volunteer slate.
Obviously, he knows what. Yeah.
Okay, slate.
Isn't it just single? So it's like 3 natural log of x squared over x.
Yeah, that's right.
Yeah.
Okay, so I think we did.
No, I'm not scared, bro. I was just saying, like, I was telling you to do it. My mom
It's-
said, bro.
Is this okay? It's okay, right? Okay, so the next one. Next one's kind of tricky. So y equal to ln of x. First period, somebody says, Mr. You can't just distribute it. If you distribute it, it's still gonna get natural x.
Wait, actually. Yeah, no.
So how do I take a derivative of this?
Isn't it? Yeah, you guys.
Say it.
No.
I thought they were on you.
You gotta be confident.
Nah.
Isn't it? Confidence.
I mean, I'm not saying this is my answer, but I thought it canceled out, you know. But
No, it doesn't
Wait, how
get
do
it
I
out. So what do you think the answer is here? It doesn't cancel out last night. I'll give you a reminder. If you take a derivative of natural log of u is equal to u prime over u.
Huh?
Vincent, what'd you get?
Is it -1 over x?
No.
What the?
How'd you get negative sign?
No, something in my head.
Did you think the natural?
No, I
You mean
didn't.
inside first?
No, I
and then-
didn't. I don't know what I did.
oh, wait a minute.
Yeah, wait, I have it.
So what would it be?
Yeah, I have it.
Is it 1 over x?
1 over x over.
Yeah. So 1 over x over natural log of x.
Huh?
So it's like 1 over x
Natural log of x.
over natural log of x.
Yep, that's correct. Because this part is u. And then if I take a derivative of this dy dx, well, we know the u we're gonna write down here. And that's 1. And now we're gonna take a derivative of natural log of x, which is 1 over x. So it'll be 1 over x natural log of x, and that's the final answer. So make sure you know that. Oh, all those 3 questions is gonna be a good test question, by the way. They are very simple, but a lot of people will screw up.
I got 56.
All right. So yeah, so that's good. Anyways. So I'm gonna give you a question like this. I say, hey, can you take a derivative? Minus 6x squared y squared minus ln of x squared y squared is equal to 10. I say fine. dy dx.
Oh,
How do I find dy dx in here? You gotta do what? No. I mean, you can, but oh no, you cannot factor out y squared because the y squared is within the argument.
the 10 just goes away, right?
What?
Away, right?
Where's the tangent come from?
Oh, the 10. Yeah.
Where's the 10? Oh, 10 will go away after you take a derivative, yes.
Yes. Let's go. Oh, we did it.
But what kind of derivative is this? Thank you, implicit.
Oh.
Very nice, very nice. Okay, so if implicit, you have to pay attention to this parenthesis because this inside the parenthesis has a product rule. And I'm just gonna go -6, and I'm gonna put a parenthesis right here. I'm gonna do a product rule, but with the implicit derivative. If you guys remember how to do that, it's gonna be 2x y squared, no, plus x squared times 2y dy dx. And this I will change to ln of x squared plus ln of y squared, just because that becomes add, and I'll change to 2 ln of x equal to ln of y. Does that make sense? And when I take a derivative, it's easier. Now I'm going to take a derivative of that. It'd be -2 1 over x minus 2 is a plus -2 what? Y prime over y. Does that make sense? Equal to 0. I'm going to change that y prime though. I'm going to change that y prime to dy dx so that way it's easier to recognize. Any question what I just did? So this is the implicit derivative. Now what happened is I'm going to distribute this. -12x y squared plus 2x squared y minus 2 over x.
Want to do minus?
Yeah, minus and -12 actually. Right?
Yeah. Oh, yeah. Pretty good.
Minus 2 dy dx over y is equal to 0. So the term that's with dy dx, I'm going to focus on those, which is this one and this one. I'm going to isolate those, everything else moving to the right. So that's equal to 2 over x becomes positive plus 12xy squared. And I'm going to factor dy dx here. Once you factor out, it's going to be -12x squared y minus 2 over y. Questions? Now I'm gonna move I'm gonna move dy dx, isolate them. So it'll be 2 over x plus 12xy all over -12x squared y minus 2 over y. And you're gonna be like, yeah, I solved the problem, but there was a complex fraction. Where's the problem? Right here and right here, right? There's a complex fraction. You can combine fraction, but takes a long time. I'm gonna show you a trick. You can multiply by these two fractions common denominator. What's common denominator between 1 over x and 1 over y? It's xy, right? So can I just multiply top and bottom by xy? What's cool thing is this, if I multiply this xy, they're gonna cancel out very naturally. So x will cancel out the bottom x here, so it'll be 2y minus 12x squared y to the third over negative 12x3 y to the 2 minus 2xy. And this will be,
plus 12.
yeah, plus. Getting sleepy.
Maybe just minus 2x. Just find the bottom, because you already took out the y.
I didn't take out y. Oh, it should be x cubed then. Yeah, this is x cubed.
No, the minus 2xy.
At the end, it's minus the denominator.
Oh, minus 2x, yeah, right. Oh, shoot. Let me redo that again. So, minus 12 extra 3 y squared minus 2x. Is that right?
Yeah.
Thank you. It's sleepy.
Your best statement, Sushi?
I do actually. You can have one. Anybody else want breast stick? We love.
I will always think of best.
Not hungry right now, I'll be honest.
All right, so is that okay? So you can have application implicit derivative today. And you can also have chapter 3, which is can you find extrema and inflection points? So I'm gonna give you questions here. How much time I have?
13 minutes.
13 minutes?
Yeah.
Okay, that's good enough time. So I can talk about this in detail. So we're gonna show you question 82. Y equal, this is one of your homework question and could be your test questions here. Whatever I go over today, it's all gonna be on the test. So, and the yesterday stuff also be on the test. So, yeah. This one here, I say, hey, can you find the extremas? Extrema is relative max and relative min. And find inflection points. Okay. How do you find extremas? First derivative, good. Can you tell me what's the first derivative here? Quotient rule, good. Can you use quotient rule here? X times 1 over x minus ln of x over x squared. Is that hard? Low d high, high d low, over low low. Did anybody still remember that? It's like in back storage closet. It's coming back.
Wait, wouldn't the x times 1 over x just turn into 1?
Yeah, I changed to 1.
Oh.
That's nice. Dyslexic. That's not you tired.
Yeah, I think so.
You good? Okay. All right. So the problem is number line test. A lot of you guys don't know how to do number line test here. So you set top equal to 0. Find critical number. If it bottom equal to 0, that's just x equal to 0. And if you set that equal to this is 1 equal to natural log of x. And then how do you solve for x here? 1 equal to natural log of x. How do you solve for x? E to the both sides. So it'll be e to the 1, e to the natural log of x. And e and natural log, you have to raise the power too. You have to raise to the things. So it's not, so it'll be e equal to x. So when you do a number line test, you have to be cautious. So that's gonna be e 0. Why do I not do anything less than 0? Because natural log of negative number, it does not exist. So you're gonna just pick a value between 0 to e. What's good value to put between 0 to e? 1? Okay, so natural log of 1 is what? No. Natural log of 1 is what? No.
It's 0.
0. Good. All right. All right. Okay, what's any value bigger than e? 3, but it doesn't help you if you don't have calculator. Now what you can do is I will actually pick e squared. Why do I pick e squared? Because natural log of e squared is what? One minus natural log of e squared. What is it? L and e will do what? Cancel, right? So that's equal to -1. So it's negative. So it'll be increasing, decreasing. So x equal to e is the relative maximum. Am I going too fast? Okay, tell me where. I try e squared. E squared is bigger than e, right?
No, or like between 0 and e, you determine as positive. That's when you plug in, you get 0.
Yeah, so 1 minus 0 is what? Amio's not awake today. All right, so how do I figure out what a y value is? Well, I can plug in e to the original function. So it'll be natural log of e over e, which is natural log of e over e is just 1, right? So it'll be 1 over e. That's actually relative maximum.
Wait, can you repeat that real quick?
I'll plug in all the way here
Oh.
to get output. Got it? What do you mean? That could be like a meal. Could be like nasty look.
plug it to the top one. You plug 1 to 1.
I plug in e. I didn't pick
The
it.
natural log cancels out, so it's 1, and then the bottom is x, so it's e, so it's 1 over e. Yeah. Oh.
Okay, let's do the inflection point. What do I supposed to do inflection point? dy dx is equal to 1 minus natural log of x over x squared. So we're going to do second derivative. Okay, low. D high minus high D low over low low. Oh, I screwed up on last few. Negative x minus 2x plus 2x ln of x, I think. That's second derivative notation. Minus 3x plus 2x ln of x over x to the 4. I can factor out x. So it'll be -3 plus 2 ln of x over x to the third, x to the 4th, sorry. And this will cancel out. That's 3. That's 1. So that's equal to -3 plus 2 ln of x over x to the 3. Got it? Can you find critical number for me? I already did the hard part. Can you do the easy part? Maybe. Can I set top equal to 0? Can I solve for it? What do I do next? How do I get x by itself? E not ex, e to the ln of x equal to e to the 3 over 2, x equal to 3 over 2, x cube equal to 0, x equal to 0. So we are doing from, we're doing from, huh? Yeah, I got 3 half. E to the 3, oh, I didn't write down e. I'm on crack. Okay, so e to the 3 over 2, 0. I will not repeat myself.
Aren't you recording?
Well. Okay, what's a good number to plug in? Between 0 to e to the 3 over 2. You stick with 1? Okay, so if what happened if you plug in 1 plus 2 ln of 1, that's going to be negative, right? It's concave down, right? And then if I plug in e squared, so it will become positive. So here I will try e squared. And then minus 3 plus 2 ln of e squared. This will cancel out. This is minus 3 plus 4. That's equal to positive. And this I will try 1. And I got this. So inflection point is at e to the 3 over 2. And if I plug in that original function, what am I going to get? Let me see. 3 over 2 divided by 3 e to the 3 over 2. So e to the 3 over 2 and 3 over 2 e to the half. So 3 over square root e. And that was my answer here for inflection point.
You put the no.
So we go over a couple simple natural log derivative. We went over some implicit derivative. We also went over relative extrema and inflection points. The question you will have most problem at extrema inflection point. I'll give you 5 questions to practice. Yeah. So, Vincent, you okay?
Yeah.
You get it?
Is it e to the third or just like square root e?
3 over 2? Yeah, e to the... Oh yeah, this is 3, right? Questions? Okay, that's it for today. I'll post homework questions. What time we get off? Oh, perfect, on time. Yay.